So when we do u substitutions, we're looking for a function and its derivative. So if I have this, f of g of x, if I have a composite function, for me to find the antiderivative, I'm going to need the derivative of that inside function in the integral. It's just the chain rule. So I need to also see g prime of x. And it's always hard to figure out what you want u to be, but usually I want to see u, and then I want to see the derivative of whatever you called u. Okay, so the antiderivative of this function is the antiderivative of little f of x plus c. This is just trying to reverse the chain rule, and I can't always see the chain rule very well unless I make it an easier problem. And you're always going to match this up with whatever's on that blue sheet. Okay, everything that's on the blue sheet, everything has to look like one of those. So it's kind of easy. How do I know I did that right? Take the derivative. So what is the derivative of capital F of x? It's f prime of g of x. And then times what? G prime of x. What is the capital F prime of g of x? It's little f of g of x. So that's how I prove that is really the antiderivative. If I don't have this piece in the problem, I'm going to either have to do some algebraic tricks to change it, or I'm just not going to be able to do it. Most integrals can't be done, actually. Usually you do like a Riemann sum program. Oh, well, let me forget that. I forgot to do that. Okay, so let's go back and do this. Can you guys see in the back okay? With all the light? Now, we did this one, depending on which day you were here, yesterday or Wednesday. I'm looking for a function, and I'm looking for its derivative. I'm tempted to say u equals the secant of x, and I can do that, by the way. It does work. Because if u is equal to the secant of x, then what's the derivative of u? What's the derivative of secant? Secant tangent. Well, guess what? I have that. So if you want me to do the problem that way, I will, or I'm going to go back and do the problem the way we did it before. Okay, so the way we did it before is we let u equal what? Secant squared didn't work either. Tangent of x, right? What I'm going to do is change. We're still going to do the u substitution, but how we finish the problem is going to be different because now I have limits of integration up here. So what's du? Secant squared of x dx. Substituting into my integral, and if you recall I said don't put the limits of integration in because what variable do they refer to? That's x. And when you get your integral here, all the letters have to match. They all have to match. Maybe if we did write x equals 0 and we wrote that out, maybe it would be easier to get this right. Because what they're going to do on the exam is they're going to give you an integral like this, and they're going to say, which one of these is the correct u substitution? So if you end up putting in the x values here in the limits, that's not correct. You know it's going to be a choice. So let's see. I've got, this is u. This is du. I'm going to show you what we're going to do. So this is u du. Now what we did yesterday is we integrated it, and then we changed back to the x's. And you could do that. But if they're asking you just for the integral, the definite integral, you're in trouble. You have to be able to change it, the whole thing over. And this is going to be u equals, and this is u equals. All these letters have to match. And you're saying, well, how am I going to find that out? Well, when x is equal to 0, then u is equal to what? You're going to put that right in there. I have to do that either now or I do it later. I like to do it now. It's the tangent of 0. Do you guys remember what the tangent of 0 is? That's 0. Okay, the next one's trickier. X is equal to minus pi over 4. I'm going to put that in there for x. So u is equal to the tangent of negative pi over 4. And there are a couple ways to find that one. Well, there's a negative sign in there. We can do it this way. There's 3 ways to do it. We can remember this little trick. All students take calc, which says the cosine is positive in this 4th quadrant, so the tangent has to be negative. Or I could be looking at it like this, and well, this is the tangent of a what angle? 45, right, negative 45, which is here. And if you draw your little triangle, and by the way, tangent is the slope of the tangent line, and there's no surprises there. Okay, so it's still going to be negative 1. Or, if I'm really thinking, I can remember that tangent is an even or odd function. Let's draw the picture. It's odd, right? So if this is pi over 4, this is minus pi over 4. Do you remember about even and odds? F of minus x, if it's odd, is what? Minus f of x. So I could do any one of those, and I can really say this is negative tangent of pi over 4. And what's the tangent of a 45-degree angle? That's 1. So that's negative 1. Okay, so let's see. This is negative 1, and this was 0. Do I have them in the right places? Let me double check, because it's easy to put them in the wrong places.
So the answer for the U substitution, you have 0.
They ask you for the U substitution, finding the correct integral. This would be one answer. The other answer would be u du minus pi over 4 to 0, and that would be wrong. Okay, Andrew? That would be wrong. So we don't want to do that. So you have to be able to change it. Now, if it's like one question on the exam, it's not going to happen more than that. So if you want to always change back to x's, you can. I'm still going to do the same work. It's either I do it now before I integrate, or I integrate, change back to x's, and do it then. I mean, it's still the same work. I personally like to do it now and just be done with the x's, just because it's easier. So what is the antiderivative of this? Of u to the first. Notice it's just the power rule. U squared over 2. And we will evaluate it at negative 1 and 0. Some of you don't like to use your parentheses. I highly recommend you do that. I know it seems silly. You guys know that that's going to be 0, but we're going to mess up our signs. And then this is negative 1 squared. I must put that in parentheses or it will be wrong. Well, I could do 2 wrongs to make it right. But this is minus 1/2. I didn't have to go back to the x's. If you want me to, and I didn't second off, if you want me to go back and do it by changing back to the x's, just so you can see it's exactly the same thing. It's a matter of when you evaluate it with the pi over 4, negative pi over 4 and 0. So you want me to do it the other way? I personally like to change it all over and just be done. I don't like to have to go back to x, because this is going to be the tangent squared of 2, evaluated at 0 minus pi over 4, which is what I already did. So it's still the same thing. Let's try another problem. Let's try 57. You assigned the odds on this one. We are doing day 2. The blue worksheet on substitution is the white worksheet on substitution, and all we really need to be able to do are A, B, and D. But for those of you who like a challenge, you might want to try C and E. Yes, 25 through 43 odd. And please do the AP prep. Considering that's an AP problem, and we're taking an AP exam. This one's really ugly looking, and it's not easy. And you may have some other ones you have questions on from earlier in the assignments. Okay, here's my first issue with this problem. Personally, do you guys like the thetas? I don't like the thetas. Now, if you go out and do physics, you're going to be working with thetas. But this is a math class, so let's just change them to x. Is it going to change the value at all? No. Please ask when you don't understand something that I'm doing, okay? Because I know what that's like. It is not fun, because then you tune out the rest of the whole thing. Oh.
Sorry, check one out.
Nope, I put the 3/2 in the wrong place. Let's try that again. Weird, because that usually works before. Anyway, 3/2 squared, and this is dx. Hard part is figuring out what u is. After I get u, it's not that bad. I'm looking for a function and its derivative. If I let u equal the square root of x, what's the derivative of the square root? It's x to the what? Negative 1/2. I don't see an x to the negative 1/2. I can't just, I could bring this up and make that negative 2 if I want, but that's still going to be a positive 3/2. So instead, what would be maybe a better u substitution? Say that again? Okay, 1 plus x to the 3/2. You could do x to the 3/2. It'll still work. It's nicer to do the 1 plus, because when I take its derivative, the 1 is going to go away. If that had been an x, then that'd be a different matter. So the derivative of this is 3/2, and then we're going to subtract 1, so it's x to the 1/2 dx, or I can write it this way. It's 3/2 square root of x dx. And that's what du is. And it's really important to keep track of those details. Because when I do my pre-algebra class, they just like to throw negative signs away. It's a detail. If it's 10 minus 2x, they say the answer is 8. No, it's 10 minus 2x. 2x and 10, they're not the same kind of thing, so you can't do that. So those of you who don't put the dx in, you're kind of doing the same thing. You're just ignoring something that's really critical. Okay, so I have this right here. Well, guess what? I've got it right here. Well, I don't want 3/2, so what do I have to do? Multiply by 2/3. And you know what else we're going to do? We're going to pull all those constants out in front, because they're just in the way. So I'm going to take the 10 out, so it's 10, and then I'm going to substitute what dx is. X square root of x dx is 2/3 of du. So I've taken the 10 out, I'm just going to put a little check mark, make sure I get everything, and then this is equal to 2/3 du. So I'm going to take the 2/3 out as well. So this is du, and in the denominator, what do I have? U squared. In your physics C, you have any antiderivatives this hard? No. Okay, so this is 20/3. How am I going to integrate that? Jimmy, how am I going to integrate that? I have du over u squared. Because this is the du, the square root of x dx, right over here. It's a multiple of the du. And then this, we had let u be equal to 1 plus x to the 3/2 right in here. And so I just substitute it in, and I can't do that. Doesn't look like the power rule. At least not yet. Make it u to the what? -2 du. And some of you get so wrapped up with doing the problem, then you forget to integrate it. Don't forget to integrate. We haven't done that yet. Okay, all of this is algebra, actually. So a little calculus there. So it's 20/3. Now to do the calculus. And so what's the antiderivative of that? U to the what? -1 over -1. Oh, and I have some limits of integration here. Let's figure out what they are. I forgot. Okay, if u is equal to this, when x equals 0, what's u equal to? Just put 0 in right in there. It's 1. When x is equal to 1, what's u equal to? It's 1 plus 1 to the 3/2. What's 1 to any power? 1. So this is what? 2. Now I got to make sure I put them in the right place, because you know as a choice on the exam, they're going to have the limits reversed. They're very good at putting in those distractors. Okay, so 0 is on the bottom limit. 0 gave me 1. And then this was the top limit, so this can be 2. So from 1 to 2. And now I don't have to go back to the x's. I really don't want to. So I'm going to pull the constant out. So I'm going to get negative 20 thirds. And I'm going to evaluate u to the negative 1, but I don't like negative exponents. So it's what? 1 over u at 2 and 1. So it's negative 20 thirds. So it's 1/2 minus 1. What's 1/2 take away 1? Negative 1/2. 2 negatives make a positive. So that'll become positive. 2 goes in once, goes in 10 times. So it's 10 thirds. Remember, an integral is a signed area. So more of this graph is above the x-axis than below. Who knows? I don't even no idea what that looks like. Between 0 and 1. Now, if it's a calculator question on the exam, yeah. If it's a calculator question on the exam, I wouldn't do all this work. I would type it in my calculator and just be done with it. Don't forget. So I always tell students, I said, when you get to the calculator part of the exam, take your calculator out and put it on your paper. Because if they ask for a derivative at a point, don't take the derivative, use n derive. Most likely you'll do it wrong. You can do that, but remember it's a time test. So you don't want to run out of time. Were there some other questions on this that you might have? I'm sorry, what? Any of these that you want to look at? Nobody came in to see me. Oh, you don't have to do 66. We should do 66. 33 is another good one. Let's do 33. First off, I don't like the way it's written. Because I can't, I mean, I know I do sine and cosine. I see that all the time written like that, but log I don't see very often. So I'd rather write it this way. It's the log of x, and you'll see this much faster this way than the other way. Now you got to tell me what the u is. Because, why is it the log of x? Alexis? Why am I going to use u equal to ln of x? Because what's its derivative? Yes. Once, are you starting to see the u substitution a little bit easier? And it all has to look like whatever is on that blue sheet. So this is going to be, this is u to the 6th. And this, you recognize that that's the same as that. So this is easy. What is this going to give you? U to the what? Yes. So what's this going to be? U to the 7th over 7 plus c. And now we have to go back to the x's. If this were on a multiple choice question, they might give you that for an answer, and they might give you something else with the x's for an answer. You have to, don't just jump at the first thing you see. Because I have to go back to the x's, so it's the natural log of x to the 7th over 7 plus c. Another option on the exam is if they give you an antiderivative, you can look through all the answers and differentiate them and see which one works. Usually for me it's easier just to do the problem. Plus it's a quick check. You have a double check there. If you do the problem, take the derivative of the answer you found on the multiple choice and see if it's the one you started with. And if it is, that's great. If it's not, you know something's wrong. I'm going to challenge you with 66. I don't think we assigned it. I don't know. I have to look. And that's unfortunate because this is the type of problem that's on the exam. There are going to be lots of logs and exponentials. Give it a try. See if you can try and get all the way to the, work only with the u's. Let's see. Yeah, they should have assigned that. I'm looking for where the quiz for the AP preparation is. Oh, the quiz for the AP preparation is on page 349. In the next problems. Is anybody, Cole, have you thought about what the U would be here?
Yeah.
Actually, it can be either way. So what do you guys want it to be? 3 plus e to the x? You can do it either way. This is probably the easier way. So what's du? E to the x dx. Hey, Cole, do you want to come up and do this?
Do it, Paul. Do it.
What's this one? What's this equal to? Du. And the denominator is u. What are the limits of integration? When x equals 0, u is equal to 3 plus e to the 0. So what's that? 4. Rest assured, one of the answers will be as if you had assumed that that was 0. It's 3, but it's 4. And when x is equal to 2, u equals 3 plus e squared. Okay? What is that antiderivative? Yes, the natural log. If you didn't catch this the first time, it's the absolute value of u. Now, I don't need absolute value because these are positive, but I'm going to put it in anyway. Plus c. And then, oh, there's no c. That's right. We're doing a definite integral. But that's okay. The c's will cancel out. So it's the natural log, and they will not dock you points for keeping the absolute value, even though it's unnecessary. It's okay, because it's still true. And it's going to be minus the natural log of 4. How could I write this a little differently if it's a matching question? If I have the log of something minus the log of something, it's a property. Yes? Can I take the log, make this log of 3 plus the log of e squared? That's it. Best I can do. Now, I know that one wasn't assigned, but you're still responsible for a problem like that. Monday is a very important